Hi, this is Suchi, and in our today's video, we are going to talk about integer. In our previous video, we actually talked about the strings. But if you remember, while we defined a string, we never mentioned that this is a string. But how we will verify whether it is a string or not? So, as you already know that description is the variable name of string data type. But we have never mentioned the data type, so how it happened? Then let's first check what is the data type of this variable. So how to check the data type in Python is we can use this type function. And inside this type, let me just zoom into it so that you can see it better. Inside this type function, type method, we can just send the variable name. So if I run this cell, we can see the data type of this variable is string. We can also print it. So you can see the data type of this variable is a class, string class. But how Python determined that? So Python is actually a dynamically typed language. While it is running the code, it actually determines the variable data type by its value. So as we have assigned a string value to this variable, it has automatically made the data type of this variable as a string. So this is a very convenient way because we do not need to worry about declaring different type of variables and all. For integer, as you know already, that integer is a numeric value. So number of students in a class. So that will be an integer number. Although it cannot be negative, but integer numbers can be negative or 0 or positive. So basically, positive whole numbers. No fraction part should be there. So number of students may be 0. So we can print it. We can print the type of this. You can see that it is integer. So if you can't relate to this example for negative numbers, let us take the example of a lift. So a lift where we have underground floor also. So maybe floor number can be negative, floor number can be -1, 0, 1, 2, 3, 4. If it is a 5-story building. So this is one example. Floors. So let's say I want to go to the floor number 2. So this floor will be what? Floor will be an integer. So if you will check the type of this floor, it will be an integer. So let me just comment out this part. So you can see the floor number is integer. But how Python determined that? Just by the value. Now, there is one interesting thing in Python. In many programming languages, we have to think of, based on the precision of the number, we have to think of which data type suits the best. For example, in Java, we have integer, we have int, we have long int, we have big int, we have small. So many choices are there, and we have to decide based on the application or based on the variable type. We have to decide that, okay, this variable might have a big value, then I can use the long, or this might have a small value, then I can use the small int or something. But Python takes care of the storage utilization by itself. And no matter how much big value we are adding here, let's say I'm adding a very big value here, Python will still consider it as an integer. So we don't need to worry about the precision of the value. It will still be integer. if we do not add any decimal point. So this is how we can work with integers. Let's say I am going to the underground floor and I added -1. So this will still be an integer. So until and unless this is a fraction, Python will consider it as an integer. So any whole number, negative, positive, 0, with any precision, Python will consider it as an integer. Let's look at some error scenarios. So for example, if I want to add some value, some integer value starting with 0. So let's say I'm saying 04. So what do you think will happen? So if I try to print it, it will actually give an error. So let me run this cell. So what it says syntax error. Leading zeros in decimal integer literals are not permitted. What it is saying leading zeros are not actually allowed in any number, in any numeric value. Let it be integer. So here it is a decimal integer literal. So it is saying leading zero is not allowed. So we cannot add a leading zero to an integer. We can add any binary value, octal value. Let's say we have the binary value or the octal value or hexadecimal value, but we want to see the decimal integer value. In Python, if we have an variable myInt and if we add a 0 at the beginning, after that I will add a small b and then I will add the binary value. Then I will add the binary value. Let me add 1111, which is actually the binary representation of 15. So if I print this, what do you think will happen? It will actually print the decimal value of this binary 1. So let me run this cell. So you can see we are getting the decimal value of this binary value. So if we want to convert a binary value quickly to a decimal value, we can easily use this method. So this is how we can easily do that. Now, what about octal value? If we have an octal value and we want to create an integer in Python. So this is for binary to decimal. Now we will do a octal to decimal. So how we will do that is, we can add a 0 and then what we will add? We'll add O from this octal, a small o. So here also what we did, from binary we added small b. So we added 0b for binary. So we will add 0o for octal. This is so simple. The initial of this number system we will add, but in small letters. After that we will add the actual number. So let me add some octal number. Let's say 11. For octal number system, the base is 8. So we have 0 to 7. After 7, it will be 10. And then 11 is 9. So if we print this, we will get 9. So as you can see, we can easily convert binary to decimal, octal to decimal. Now what about hexadecimal? The same logic goes here for hexadecimal. But for hexadecimal, this H will not work. What will happen? we have to use the x instead. So for hex, we will use x. So 0x, and then we will add the hexadecimal value. For example, let's say A, B. So if we will add this, we will say print. So it will give the decimal equivalent of this hexadecimal value, which is 171. So if we will only add A, what we can see is 10. So it's working fine. So this is how we can easily convert the value from any other number system to our decimal number system with just using a prefix to it and then assigning to a variable. Now, we might have the number in a string and we might need it to be converted into a decimal value. We have this number as a string. How we can do this? There is this method, int method. So using int, we can actually convert value into integer. Let us look into this, how we can do that. So let's say from binary, what we can do? We can add the binary number here in the string format. So this is a binary number, and then we can add the base of the number system from which we are trying to convert. So for binary, the base is 2. So we will add 2 here. So this will be giving me the decimal value. So let me print it. So you can see the converted binary to decimal is 15. Now what we can do is we can do the same thing for octal. We will add OCT here just to make the name meaningful so that we can remember this. And then base is 8 for octal. So what we can do is base we will add at 8 as 8, and for 15 what is the octal value? Value is 17. So if 17 is converted into octal to decimal, what it will be? It will become 15. So we will run this. So as you can see, the conversion has happened correctly. Now from the hexadecimal, we will do the same thing. So we will write from hex. We will write from hex, and then base of hexadecimal is 16. So I will just run this with 16 base, and here I will add. What I will add here is I want the equivalent 15. I want the equivalent of 15 here. So I know it is f, so I will add f. So you can see f will be converted to decimal and it will become 15. So here we can see. So this I should change to octal. This is hexadecimal. You can see. So all the conversions are giving me the correct value with this int function. So int, and then I have to pass the value in string format in some other number system, and I have to provide the radix. I have to provide the base of that number system so that it can easily convert it into decimal number system. So this is how we can easily convert any other number system. So this is how we can convert any value from other number system to a decimal integer. Now, one important thing I want to tell you here in Python, we cannot actually concatenate a string with a numeric or other type of value. So, for example, in many other programming languages, we see this syntax. Result, and then we can use a plus sign, and then we can use some integer value. For example, let's say this one, or if I add this, what will happen is Python will throw an error because this is an integer type variable, and let me just have it like this. Let me add it here. And then what I will do is I'll add one integer here. So here I will add this integer. So if I try to concatenate, if I try to use a plus operator between one string and an integer, not inside print statement, even if we add this same expression outside print statement, let's say final is equal to this, and I want to print this final. So let's say print statement, let me have it commented out for now. So if I try to add one string with an integer or any other numeric value, non-string value, what will happen is it will throw me an error. What is that error? It is saying can only concatenate string, not integer, to string. So we can only concatenate string with a string. We cannot concatenate any other non-string value with a string. And so this is a very important thing in Python. We have to keep on mind, because we have a normal habit of doing this thing. For example, result, and then we add a plus symbol, and then we add our integer, and we try to print it. So then we will get this same error. So what we need to do in this scenario is either we can add one comma here in the print statement. So if we will add comma, it is not necessarily be two things. We can have any number of things here. X, Y, Z. We can have any number of things, any number of parameters here in print statement, and it will actually print all of them with a spacing, with a space in between. We can actually print multiple things with a space in between. So by default, the space is the separator. But if we do not want any space and we want to print them without any space, then what we can do is we can actually use this ACP attribute, ACP parameter, and we can assign some value. So it could be anything. If we want it as a new line, we can add a new line \n. So you can see this is actually printed in new lines. If we want something else, for example, this pipe operator, so we can add this and we can just run it. You can see a pipe in between. We can add something else. We can add anything which we want to be as a separator. So this thing we can use. Another way of doing this is if we actually want to concatenate it, it is just not about printing. We actually want to concatenate this string to this value. In that case, what we can do is there is a function string, str method. So which is str, this thing, str. And if we pass any value inside this, it will actually return a variable of string type. So it will actually typecast. It will actually cast the type of that variable, whatever variable we are passing inside this, let's say my int. So it will actually cast that into string type, as you can see here, string type. So what we can do is we can actually add this str function here, and it will be casting it into a string. Now this is also a string and this is also a string, so it will be easily concatenated. There will not, we will not get any error here. So I'll just add a print statement here just to show you what is the value of it. Let me comment out this part, and as you can see, the concatenation happened correctly. No error thrown. So there, this string str method comes under play. That's it for today. Keep implementing, and we will discuss the rest of the things in our upcoming videos. Thank you for watching.